So in my discussion of this activity, I'm going to look at screens 1 through 7 and then ask you to consider your answers to those screens and then correct any mistakes you've made and then look at your answers for problems 8 through 15 and decide if there are any problems that you should go back and correct. So in problem 612, you are being asked to check out side, 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 see if it actually works as a congruency rule. So if I click on AB and move it and move the icon over to DE, that guarantees those will stay the same length. And if I do the same thing for the other two pairs of sides, or corresponding sides that currently have the same measurement, the question they're asking is if I move the triangles, do the triangles remain congruent? So we do have the same angle measurements, the side lengths remain the same, the shape remains the same. So it appears, just based on everything here, that the triangles are always the same. So we're looking at similar triangles based on the angle measurements and shape. It's kind of that first part we talked about from Monday, and we have a scale factor of 1 for the corresponding sides. And so this is what we're basically looking for in terms of congruency. Do we have triangles that are similar based on the shape, the angle measurements, the scale factor of the sides, and does it remain the same? And if the scale factor remains 1 as we manipulate these triangles, then we're talking about triangles not only are similar because of the angles and the shape, but also are congruent because the scale factor is 1. And hypotenuse leg, what we're trying to make sure here is that the triangles remain right angles. And I'm going to guess that you had the same difficulty I had with this one. The shape just appeared to be off the screen. So we got to make sure here in this triangle work is that the angles remain a right angle, and you maintain a hypotenuse leg. So I'm going to let angle D and angle A be the right angle, and we'll definitely make that a right angle. We're going to let the 10.3s be the same, and then I need to make sure that I have also a leg that's the same. So in terms of making the right angle, we're going to do our best to make the angle a right angle, and in doing so, the angle measurements match up, the side lengths match up. If I move the triangle again and again try to make it into a right angle, that's the key here. Do I get the same numbers? And I get 9.3, 3.4, 9.9. I have a right angle. Again, the angles still match up. So the idea here is can I make the situation not work? Or if I continue to move this, will I always end up with a right triangle where the angles are the same and the triangles have the same shape? And the answer again is yes. The corresponding sides have a scale factor of 1. So this one here, we're getting the same situation that we did in the previous problem, which was the side problem. And hypotenuse leg, also we can go one step further. Because of the Pythagorean theorem, we could actually solve for the third side, and that actually makes a side situation in both triangles. So sometimes using our previous rule can also be a great support for why another rule will also work. For angle, 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 we want to make sure is the angles stay the same. So the blue angle, the red angle, and the green angle, everything's the same. We're not looking at the whether or not the we're not matching sides up. All we're looking at is the angle. And if you notice, if you try to make the triangles the same, it's not possible. And one of the reasons why, because since you don't have any side lengths, it's really hard to guarantee that the two side lengths are corresponding sides are going to be the same. I'm not saying that it's not possible. It's just very challenging, and based on the construction of this one here, it appears to never work. It appears that we can never get the triangles to be the same shape because we don't have any side lengths. So the triangles do remain similar, but scale factor between the corresponding sides is not a 1 because we don't have the numbers that are the same. Now the difference between angle, angle, angle and angle, angle, side is that with angle, 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 we don't have any side lengths. All we're given are angles, and so we cannot guarantee with angle, angle, angle the triangles can never be congruent, because without the side length numbers, we cannot get a scale factor of 1. But this is different, and here we're going to have a pair of angles that remain the same. So I'm going to go ahead and choose these two angles. And we have a side. Now the side itself is not included. It's not between the two angles. So that would mean I could choose this side here, and that's the 6.4 goes to here. So we have angle, angle, side, angle, angle, side. And we're trying to do again, if I move these triangles around and stop at different places, do the triangles remain the same? And you'll notice the angles are the same, the shape's the same, the side lengths remain the same. And if we continue to move the triangles to different locations, it doesn't appear, based on the investigation, it doesn't appear we are going to get different triangles. So this one here always appears to work. For side-side angle, now the side-side angle, we have lots of cases to look at here, but again, I'm going to take the general case of side-side angle, so I'm going to put the 5.9 to 5.9, and we're going to do the 8.9 to the 8.9, so that's my side, and then the angle we're going to use is the 40-degree angle to the 40-degree angle. And the question is, with this side-side angle case, are the triangles going to be the same? Can I make them look different? So part of this is that you have to think about all the things that we've been doing. And if I have a situation where I have short side, long side angle, it is possible the triangles can be different. Whether we can get those triangles to be different here based on this sketch, that part I don't know, but the triangles can be different. When I have long side, short side angle, as we talked about back in chapter 3, as well as in the chapters 4 and 5, we're going to get one triangle. So in this case here, it doesn't always work. And the reason why it doesn't always work is because it is possible to have that short side, long side angle and get two different triangles. So a lot of this depends on the information you're given, and as long as you get that long side, short side, we're definitely looking at congruent triangles. Angle side angle, real similar to angle angle side. The difference is that this time the angle is between the two sides. So I'm going to do the 50-degree angle, going to this 50. The 81 going to the 81, and this time the side is included. So here's my angle side angle, and if I manipulate the triangles? Do I get the same shape? And so in this one here, hopefully you see that the answer is yes. Keep in mind that because we have angle, so the 38 and the 46, for example, as long as we have two angles that are always going to remain the same, that guarantees the triangles are going to be similar. And because we got a scale factor of 1 between the AB and DE, that's going to guarantee the shape of the triangles are going to be the same. So this one here is an always works. Because again, similar by angle, and we have a scale factor 1 between a pair of corresponding sides. So in this activity, the ones that worked, the side worked because we have the side similarity rule, and scale factors 1, which makes the triangles congruent. Hypotenuse leg always works because we can use side as a justification with Pythagorean theorem. But again, we have similar triangles based on hypotenuse leg similarity, and then the scale factor between the hypotenuses and the legs is 1. Angle doesn't always work. Actually, the chance of it working is extremely small because we don't have a side length. So therefore, this is doesn't work until we add in the side. That's where angle side comes in at, and angle comes in at. These two rules here basically are angle with an added side length. And by adding the side length, we can take the angle and say, now this is going to work in both cases because we have a scale factor of 1, where that's not possible with angle. And then the last one, side angle, it doesn't always work as a congruence rule. We do have a situation where it does work, and that's when we have long side, short side angle. And so I'm not going to check this one because side angle doesn't always work. But just keep in mind that because long side, short side angle does work as a similarity rule, if we have long side, short side angle, it will work as a congruency rule because the similarity rule already exists, and we will have a scale factor of 1 between the corresponding sides. So think about the problems you've done and decide which answers need to be applied to these problems here. I'll give you an opportunity to correct the sketch, and then when we come back on Monday, we will finish the discussion.